again. Let's find the critical path for this network. Just having a look at it here, you can see there's all these activities which take let's call this one 5 days and 2 days and so on, and all the different activities. You'll notice here that we've got the dotted line. The dotted line represents a dummy path. Takes no time to go down a dummy path, but it just is a way of drawing these diagrams. Okay, here we go. We will start off at the beginning. We have a 0 at the beginning. Now, to get a critical path, we want the maximum times as we go along here to get the earliest start time. So the maximums, we have 0 plus 5 is 5, will get us down activity A, or a 6 will get us down activity C. Then, activity B goes straight to this middle point here. That would take 8. Or we could get there going via activity A, that's just 5 and there's no time for that, so 8 is bigger than 5, but you'll notice if we go through activity C and then activity E, that would be 6 plus 7 would be 13, and because that's the maximum we can get of those various ways of getting there, the 13 is the number that goes there. That's the earliest start time there. Take the maximum each time. So we've got 13 to get there. Then we would just take 5 more going down activity H to get to 18, but we should check the other pathways as we go along as well before we fill in that one. Let's just check all, because there's 3 different ways of getting to the end here. Activity D, we've got 5 plus the 2 makes 7. And then 7 plus 4 make 11, but I'm going to get 18 going the other way, so I'm going to hold off on that one. And then down the line through activity F, I've got 6 and 4 would make me 10. 10 and 3 would give me 13. Well, the maximum is 13 and 5 to give me 18. And that gives me the critical path. When you've found the way that adds up to the most, and in this particular network, that would be coming down here and up here and then across here. That gives me the maximum time. That is the critical path. Now, and all these numbers in the top are the earliest start times. For the latest start times, well, you can fill in down the critical path. The critical path, these two numbers will be the same. They always must be. That's 13, that's 6, and that's 0. And there is no float time down the critical path. You have no choice. To make it all finish in the quickest time possible, they have to happen. There is no float time for any of those. But there will be float times for the other activities. Now, going back the other way, we want to get the minimums we possibly can so we can go along, but we don't actually have much choices here, so it's going to be reasonably straightforward. 18 minus the activity time of 3 will give you 15 here. And similarly, 18 minus 4 will give you 14 here, and 14 minus 2 will give you 12 here. Let us find a float time for one of these activities. Let us find a float time for activity D. It is the latest start time. So when you have these little boxes, the top one is the earliest start time. Bottom one is the latest start time. And to find the float for activity D, we take the 14, the latest start time, we take away the activity time, which is 2, and we take away the earliest start time, which is 5, and that's 14 minus 7. We got a 7 hours float, or a range of 7 hours where we can start that activity in and still not affect the final finishing time. The critical path, remember, gives you the quickest way of finishing all this activity would be in 18 hours or 18 days or whatever we're measuring here. Okay, I think I will stop just there.